asteroids, we know,
Yeah?
many of them, if not most of them, are loosely held together rubble piles. And if they come near gravitational sources, tidal forces can stretch them so that they become a stream of particles rather than just one solid mass.
So this thing isn't solid?
It is likely not solid.
What if the first confirmed visitor from another star system was actually something far more incredible than we imagined? On October 19th, 2017, a mysterious object rocketed through our solar system at unbelievable speeds, leaving scientists completely baffled. Its behavior was so strange that some of the world's top researchers began asking a question that sounds like science fiction. Could this be our first encounter with alien technology? Today, we're diving deep into the mystery of Oumuamua and the shocking theories that followed its discovery, the discovery that shook the scientific world. On that October morning in 2017, astronomer Robert Werrick was doing what he did every day, reviewing telescope data from the Pan-STARRS Observatory in Hawaii. But something caught his eye that would change everything we thought we knew about visitors from space. Racing through our solar system was an object moving at the staggering speed of 59,000 miles per hour. What made this discovery so groundbreaking was where it came from. Every calculation pointed to the same incredible conclusion that this object had traveled from another star system entirely. The sun's gravity simply wasn't strong enough to capture something moving that fast. This was the first confirmed interstellar object detected passing through the solar system, earning it the Hawaiian name Oumuamua, meaning a scout, or messenger that arrives first from afar. Scientists quickly got to work measuring this cosmic visitor, and what they found was equally puzzling. The object was roughly the size of a football field, somewhere between 300 and 1,300 feet long, but the real shock came when they tried to determine its shape. Most asteroids and comets have fairly predictable shapes, roughly round or lumpy masses of rock and ice. Oumuamua was completely different. Initial observations suggested it was extremely elongated, like a giant cigar spinning through space. Some estimates made it 10 times longer than it was wide. Later studies offered a different possibility that Oumuamua might be flat and pancake-shaped instead. Either way, astronomers had never seen anything like it. The closest comparison they could find was Arakoth, a strange object in the Kuiper Belt beyond Neptune. But even that didn't come close to matching Oumuamua's bizarre proportions. As if its shape wasn't mysterious enough, the object was tumbling end over end every 7.3 hours, causing its brightness to change dramatically as different surfaces reflected sunlight back toward Earth. When astronomers spot a comet approaching the sun, they expect to see a beautiful glowing tail streaming behind it. This happens because solar heat vaporizes ice on the comet's surface, creating jets of gas and dust that get blown away by solar wind. Oumuamua threw out all the rules. Despite passing incredibly close to the sun, it showed absolutely no signs of outgassing. This lack of a tail became one of the most important clues in unraveling Oumuamua's mystery. If it wasn't releasing gas and dust like a normal comet, then what exactly was it made of? Scientists had catalogued thousands of comets over the centuries, and they all followed the same basic pattern when they got close to the sun. The fact that Oumuamua completely ignored these rules meant they were dealing with something unprecedented. Just when scientists thought Oumuamua couldn't get any stranger, they discovered something that defied all expectations. As the object rounded the sun and headed back toward interstellar space, it suddenly sped up. Oumuamua accelerated to an incredible 194,500 miles per hour, which is nearly 3.5 times faster than when it was first detected. That's fast enough to travel from New York to San Francisco in less than 3 minutes, and 5 times faster than Voyager 1, one of humanity's fastest spacecraft. Comets do sometimes accelerate when they pass the sun, but that acceleration comes from gas jets pushing them forward as ice vaporizes. Since Oumuamua showed no signs of outgassing, scientists were left scratching their heads. What force could possibly give a massive object such a significant boost? The acceleration was real and measurable, but the cause remained completely mysterious. Some researchers began to wonder if they were witnessing something that had never been seen before in the history of astronomy. This unexplained acceleration would soon lead one of Harvard's most respected scientists to propose a theory that would shock the world. Alien technology theory. Dr. Avi Loeb, one of Harvard University's most respected astronomers and former chair of their astronomy department. Along with his colleague Shmuel Billy, Loeb proposed something that sent shockwaves through the scientific community. What if Oumuamua wasn't a natural object at all? What if it was an artificial probe sent by an intelligent extraterrestrial civilization? Loeb's theory centered around something called a light sail, a revolutionary propulsion technology that uses radiation pressure from stars to accelerate spacecraft. The concept is based on real physics that we already use today. Light particles, called photons, exert tiny amounts of pressure when they hit surfaces. For a thin, lightweight sail, this pressure can provide continuous acceleration without requiring any fuel. Japan's Icaros spacecraft successfully demonstrated this technology in 2010 during its journey to Venus. According to Loeb's calculations, if Oumuamua was equipped with an ultra-thin light sail, just 0.3 to 0.9 millimeters thick, about the thickness of a human hair, the radiation pressure from our Sun could easily explain its mysterious acceleration. But Loeb went even further. If Oumuamua truly was an artificial device, it would need more than just a sail. Any interstellar probe would require systems for scanning its surroundings, collecting data, and potentially communicating with its creators. The object's strange tumbling motion could have been part of a systematic survey of our solar system, gathering information about our planets, our Sun, and possibly even detecting signs of life on Earth. The implications were staggering. If Loeb was right, humanity had just witnessed its first encounter with technology from another civilization. The object's journey time provided additional support for this theory. At Oumuamua's speed, a trip from the nearest star system would take roughly 40,000 to 50,000 years, far too long for any biological crew to survive. This suggested that if it was indeed a spacecraft, it was almost certainly an unmanned probe, either controlled by advanced artificial intelligence or following pre-programmed instructions. But not everyone in the scientific community was convinced by the alien spacecraft theory. Many researchers considered it overly speculative and began developing alternative explanations based on more conventional physics. Dr. Alan Jackson and Dr. Steve Desch from Arizona State University proposed that Oumuamua might be a fragment of frozen nitrogen that had been blasted off from a Pluto-like planet in another star system. Their theory drew inspiration from NASA's New Horizons mission, which discovered vast plains of nitrogen ice on Pluto's surface in 2015. According to Jackson and Desch, a powerful asteroid impact could have broken off a chunk of this nitrogen ice, sending it on an interstellar journey. As Oumuamua approached our Sun, the nitrogen would have begun to evaporate, creating a subtle form of jet propulsion that could explain the object's acceleration. Since nitrogen is a very light gas, it wouldn't create the visible tail that astronomers typically see from comets, which could explain why no outgassing was detected. Another compelling explanation came from Dr. Darrell Seligman of Cornell University and Dr. Jennifer Bergner of the University of California, Berkeley. They suggested that Oumuamua was once an ordinary water-rich comet that had been ejected into interstellar space millions of years ago. During its long journey through the galaxy, the comet was bombarded by powerful cosmic rays from distant supernovas and other high-energy sources. These cosmic rays could have penetrated deep into the comet's icy structure, breaking apart water molecules and converting up to a third of the ice into trapped hydrogen gas. When Oumuamua finally reached our solar system and began warming up near the Sun, this stored hydrogen would have started escaping in invisible jets, providing the thrust needed to accelerate the object. Since hydrogen is so light and produces very little visible material, this would explain both the acceleration and the lack of a detectable tail. Dr. Karen Meach, an astronomer at the University of Hawaii, offered perhaps the simplest explanation of all. She suggested that Oumuamua might just be an ordinary comet with unusually low dust content. In her view, the object's strange appearance and behavior might simply reflect how little we actually know about the diversity of objects in the universe. Most comets we've studied come from our own solar system, so encountering one from another star system with different composition and properties shouldn't be surprising. Despite the theories, the mystery of Oumuamua remained unsolved, which pushed scientists to propose a mission for real answers. Project Lyra. With Oumuamua racing away from Earth at incredible speeds, ground-based telescopes could only watch helplessly as the mysterious object faded into the darkness of space. By early 2018, even the powerful Hubble Space Telescope could no longer detect it. The object was simply too small and too far away to study from Earth. But what if humanity could send a spacecraft to catch up with Oumuamua and examine it directly? Just 11 days after Oumuamua's discovery, researchers from the Initiative for Interstellar Studies announced Project Lyra, an ambitious plan to design and launch an interstellar probe capable of intercepting the mysterious object. Leading the effort was engineer Adam Hibbard, creator of advanced trajectory calculation software used for planning interplanetary missions. According to Hibbard, such a mission would mark humanity's first deliberate attempt to send a probe beyond the solar system. The scale of this challenge cannot be overstated. By the time scientists finished their initial analysis of Oumuamua, the object was already more than 200 million miles from Earth and accelerating away at tremendous speed. Every day of delay meant millions of additional miles that a pursuit spacecraft would need to cover. The window of opportunity was closing rapidly, and with current technology, launching such a mission would require years of preparation and development. The biggest challenge was speed. Oumuamua was already billions of miles away and moving faster than any spacecraft humans had ever built. To catch up with it, a probe would need to reach speeds of at least 45 miles per second. Achieving such velocities would require the most extreme gravitational assist maneuvers ever attempted. The spacecraft would also need to be equipped with revolutionary life support systems for its instruments, as the journey would take it far beyond the protective bubble of the solar system's magnetic field into the harsh radiation environment of interstellar space. Creating a probe capable of surviving such an extreme mission presents numerous technological hurdles. The spacecraft would need to operate autonomously for decades without any possibility of repair or maintenance. Its communication systems would need to transmit data across distances so vast that radio signals would take hours to reach Earth. The probe's scientific instruments would need to function perfectly after years of exposure to cosmic radiation, extreme cold, and the constant bombardment of interstellar dust particles traveling at incredible speeds. Engineers developed several possible trajectories for the mission. The most promising involved launching the probe toward Venus for an initial speed boost, then returning to Earth for a second gravitational assist before heading to Jupiter. The gas giant's immense gravity would provide the final acceleration needed to send the spacecraft toward Oumuamua at interstellar speeds. This gravitational dance between planets had been successfully used before. Both Voyager probes used Jupiter's gravity to reach Saturn in the 1970s. An even more daring option involved the solar Oberth maneuver, where the probe would dive dangerously close to the Sun's surface before igniting its engines at the moment of closest approach. This technique could potentially accelerate the spacecraft to over 100 miles per second, but it would require revolutionary heat shield technology to survive temperatures exceeding 1,400 degrees Celsius. NASA's Parker Solar Probe had already demonstrated that such extreme solar approaches were possible, using a specially designed carbon foam heat shield to venture within 4 million miles of the Sun's surface. The mission timeline was equally challenging. To have any chance of success, the probe would need to launch between 2030 and 2033. Even with perfect execution, it wouldn't reach Oumuamua until the early 2050s, when the object would be more than 10 billion miles from Earth. At that distance, communicating with the probe would take over 15 hours each way, making real-time control impossible. The spacecraft would need to be programmed to make critical decisions on its own, including how to approach Oumuamua and what scientific measurements to prioritize during the brief encounter. One of the most intriguing aspects of Project Lyra is what it reveals about humanity's readiness to take the next step into interstellar exploration. The mission would require international cooperation on an unprecedented scale, combining the resources and expertise of multiple space agencies. It would also push the boundaries of current technology in areas ranging from advanced propulsion systems to ultra-sensitive scientific instruments capable of analyzing an object moving at interstellar speeds. But what would such a mission actually discover when it finally caught up with the mysterious interstellar visitor? The future of interstellar exploration. If Project Lyra succeeds in reaching Oumuamua, the discoveries could revolutionize our understanding of both interstellar objects and the possibility of alien technology. Most scientists expect the probe to find evidence supporting one of the conventional theories, perhaps confirming that the object is made of nitrogen ice or contains trapped hydrogen gas. Such findings would still be groundbreaking, as they would represent our first direct analysis of material from another star system. However, the possibility remains that Oumuamua could prove to be something far more extraordinary. If the object does turn out to be artificial, the implications would extend far beyond astronomy. Confirming the existence of alien technology would fundamentally change humanity's place in the universe and raise profound questions about who created it and why. Recent analysis suggests that Oumuamua's trajectory can be traced back to the Vega star system in the constellation Lyra, approximately 25 light-years from Earth. This relatively nearby stellar system could potentially harbor the civilization responsible for creating the probe, if indeed it proves to be artificial. The fact that Oumuamua arrived in our solar system just as humanity developed the technology to detect it might not be coincidence. It could represent our first contact with a galactic community of intelligent species. Even if the mission fails to reach Oumuamua directly, it would still achieve something remarkable. The probe would become humanity's first purposefully designed interstellar spacecraft, paving the way for future missions to explore the space between stars. Unlike Voyager 1 and 2, which left the solar system almost by accident, this new probe would be specifically equipped to study the interstellar medium and search for other mysterious objects. The European Space Agency is already preparing for the next interstellar visitor with their Comet Interceptor mission, scheduled to launch in 2029. This probe will be stationed at the L2 Lagrange point, about 930,000 miles from Earth, where it will wait patiently for the next interstellar object to appear. When another Oumuamua-like visitor arrives, the spacecraft will be ready to intercept it much more quickly than was possible in 2017. The search for interstellar objects has also intensified dramatically since Oumuamua's discovery. Advanced survey telescopes like the Vera Rubin Observatory will soon begin systematically scanning the sky for similar visitors, potentially detecting dozens or even hundreds of interstellar objects over the next decade. Each new discovery will help scientists understand whether Oumuamua was truly unique or just the first example of a common type of cosmic wanderer. The implications of finding more objects like Oumuamua could be profound. If future discoveries show similar unusual acceleration patterns or strange shapes, it might suggest that such phenomena are more common than previously thought. This could either strengthen the case for natural explanations or potentially support the idea that multiple artificial objects are passing through our solar system. Current telescope technology is rapidly advancing to meet this challenge. The Legacy Survey of Space and Time, conducted by the Vera Rubin Observatory, will photograph the entire southern sky every 3 nights once it becomes operational. This unprecedented surveillance capability means that future interstellar visitors won't be able to slip past us unnoticed, like Oumuamua nearly did. The telescope's advanced computer systems will automatically flag objects with unusual trajectories or characteristics, potentially giving astronomers months or even years of advance warning. Meanwhile, the broader search for extraterrestrial intelligence continues to evolve in response to Oumuamua's discovery. The Galileo project, launched in 2021 by Dr. Avi Loeb, aims to systematically search for evidence of alien technology both in space and here on Earth. Using advanced sensors and artificial intelligence, the project hopes to identify and study unexplained aerial phenomena that might represent genuine extraterrestrial visitation. The project's approach represents a significant shift from traditional SETI research, which focused primarily on radio signals from distant civilizations. The scientific community has also begun reconsidering how we might recognize alien technology when we encounter it. Oumuamua's case demonstrates that extraterrestrial artifacts might not look anything like what we expect from science fiction. Instead of obvious spacecraft with clear technological features, alien probes might be designed to blend in with natural space debris or use technologies so advanced that we struggle to recognize them as artificial. This realization has led to new protocols for investigating unusual astronomical phenomena. Whether it was a bizarre natural object or humanity's first glimpse of alien technology may remain one of the greatest unsolved mysteries of our time. But perhaps that's exactly what makes the universe so fascinating. There are still discoveries out there that can completely change how we see our place in the cosmos. What do you think Oumuamua really was? And should humanity invest in the ambitious missions needed to solve these cosmic mysteries? Share your thoughts in the comments below.